Today's lesson is on Box and Whisker Plot. So what we're going to be looking at is constructing and interpreting box and whisker plots. What they say is a box and whisker plot, it uses a number line to display a data set using your medians. So it more or less shows your distribution. It's a visual way to show that distribution of your data. So when you look at a box and whisker plot, you're going to have these things called quartiles. Okay, it divides your data into 4 equal parts. So you're going to have your first quartile, which is your median of your lower half, and you're going to have your third quartile, which is the median of the upper half. Your IQR, that interquartile range, it's going to be the difference between the third and the first. So the difference between the upper half and the lower half of your data set. It's just showing different spreads of your data. So when you construct a box and whisker plot, the first thing you always have to do is order your data from least to greatest. And then you're going to find your median, your true median of all the data. Then you find your median of the first half of the data set, which is your first quartile. Find that median of the second half of your data set, which is your third quartile. And then you find your extreme values. Draw your number line, plot those values, draw the boxes, draw horizontal lines from the boxes to each of your extremes, and then draw your vertical lines inside your boxes to represent your medians. So box and whisker plots are easier to explain as you're actually going through it. When you create your box and whisker plot, I like to say you have this 5-number summary. Okay, it's those 5 numbers that make up your box and whisker plot. So it's your median value, your first quartile value, your third quartile value, and your 2 range values. So that creates 5 different numbers. So we call that your 5-number summary. So creating a box and whisker plot. Okay, get to that once we look at your distribution of it. So when we look at shapes of your box and whisker plots, this first one here is what we consider to be skewed left, meaning a majority of your data is over here to the right, and you've got that one whisker pulling it to the left. So you look at which way your whisker is pulling, and that's considered which way it's skewed. It's skewing that data because the majority of your data is up here, but it's getting pulled by that one whisker to the left. So if you look over here all the way to the right, this one's considered skewed right. You see how a majority of your data is over here, and then you've got that one long whisker that is pulling that data set. Symmetric means when it's evenly distributed on both sides of your median value. It doesn't have to be perfect, but it's pretty close. When they're skewed left and when they're skewed right, it is pretty obvious which one it is versus when it's symmetric. So creating your box and whisker plot. It says, make your box and whisker plot, ages of the members of the U.S. women's basketball team, find the range and IQR, into your quartile range of your data. So when we do this, what I want you to do is pause your video. I'm going to write down the 5-number summary. So pause the video. You find your 5-number summary. You find your median. You find the median of the bottom, your first quartile. You find your median of the third quartile. And then you also write your range values. Step 1 is always to put it from least to greatest. Actually, I'm not going to pause this. Step 1, put your data at least to greatest. Because I want to show you something. So you have 18, 22, 22, 24, 25, 25. How many 25s? We got 3 of them. Oh boy, gonna run out of room. 30, 30. Oh, nope, made it. 30. All right. So your median values. So we have an even number of data in my data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means 6 in, 6 up, 6 down. So 1, 2, 3, 4, 5, 6. Right here is the middle of my data set. All right. It's cut right in between those two 25s. So my median, my 5-number summary, I'm going to have my median, my first quartile value, my third quartile value, and my range values. Those are the 5 pieces. So my median here, it's going to be the average of these two. So 25, 25 makes 50, divided by 2 is 25. Well, since they're the same number, it's going to be the same thing. So my first quartile then is the median of this set of data, straight up to that line. If your median was actually represented in your data set, I always tell kids, circle that median. Okay, because you're actually not going to use it then when you find the median of your first quartile or your third quartile. But when you have that even number of data in your data set, you're going to draw that line and you go right up to that line. So you're actually including every single value now. So your median of this lower half falls right here, which is going to be 23. The median of the upper half is going to fall right here, which is going to be 29. And then your range values are your lowest number, which is 18, and your highest number, which is 30. So to create your box and whisker plot, step one, there it is. Step one is draw your number line. Okay, and I'm going to start my number line at 18, and I'm going to go all the way up to 30. So 18, I'm going to count by twos though. 20, 22. Not the best, but it's difficult on here. 24, 26, 28, 30. Yeah, I'm going to just cut you back a little bit. Okay. So on my paper, I actually did it by ones, but because I'm on the board here, I can't do it. So what your next step is to plot your values, your median values. So the first one's 25. Your first quartile value is 23, so it's going to be right here. Your third quartile value is 29, so it's going to fall right here. And then your range values. So you got 30 and you've got 18. So your box is your median values. So you draw your boxes, and then the whiskers you connect to the box. There's your box and whisker plot. So the boxes create your median values, your whiskers are your range values. So what this kind of means is that this one I would consider skewed left because of this line right over here. It's that whisker is pulling it towards the left. So majority of your data falls up at the top, and you can actually look at the numbers and you can see that. I mean, a lot of these numbers, like if you kind of go from like, I'd say roughly around 24 and up, these are all pretty close together. And then you've got these numbers down here that are kind of skewed a little bit. They're a little bit further away. So it asks us to find your range, which is the highest minus the lowest. So the range of the data is going to be 12 because you're going to take 30 minus 18, so you'll get 12. Your IQR is the third quartile minus the first quartile, so 29 minus 3, which is 6. Okay, so they're not that big of a spread per se in data, but it is skewed. So pause the video, and I want you to find create the box and whisker plot for the basketball players' scores. Okay, so this one here, you can see that your median's 18, your first quartile is 15, the third quartile is 25, and your values are 5 and 30. So you create it using that, and then your range was 25, your IQR was 10. So you can see this one, it's not very, very skewed, but I would still call this one skewed left. That left whisker is still being pulled quite a bit there, so I would kind of consider it skewed left. So then you can take all this information, you can actually interpret a box and whisker plot. So here it says the box and whisker plot represents the lengths of songs in seconds played by a rock band at a concert. Find and interpret the range and IQR of the data set. So your range for this one, your high minus your low, is going to be 140. Your IQR is going to be 60. Okay, so we found those. Now it says to interpret. Now, interpretation is up for interpretation. So there is no one like completely correct answer for this. So when I look at this, I say, okay, so my range values, so my interpretation of my range would be like the song lengths vary by no more than 140 seconds, meaning from your longest to your shortest song, it's 140. So no songs are vary any differently from that. Your IQR, I would kind of say 50% of the songs vary by no more than 60 seconds. So when you're looking at a box and whisker plot, 25% of the data falls here. 25% of the data falls here. 25% of the data falls here. And 25% of your data falls here. Hence the quartiles, why they're called quartiles. It's broken up into quarters. So when I say about the IQR being 50% of the data, well, half the data falls in between here and here. So when you describe that distribution on your data set, I would describe it as 25% of the songs were between 160 and 220. So 25% were between 160 and 220, 220 seconds. 50% were between 220 and 280. So that's where 50% of that data is pretty close together in there. Majority, or not majority, but half your songs fall in between that length. And then I'd say again, 25%, I would describe that third quartile, are between 280 and 300. Okay. So when you're describing it, I would say, describing your distribution, I'd say that 25% between there, 50% between there, 25% between there, and it would be considered skewed left because of that left whisker being pulled that way. So box and whisker plots just show that distribution of that data set. Really not what I wanted to do.